Okay, so here we're going to look at determining the equation for a transformed sine or cosine function. We're going to go backwards and start with the graph and then try to get the equation. So we'll do as much as we can here just by looking at it. First of all, let me mention that if this third tick mark is pi, then each of these tick marks is pi over 3 because you're cutting pi into 3 pieces. So each of these is a pi over 3. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6, 7, 8 pi over 3. So it's important to note that our graph starts at pi over 3 and ends at 8 pi over 3, and we'll keep that in mind. Alright, so the equation of this function is going to look something like this. Y equals, and since the amplitude is 5, I know I'm going to multiply by 5. And since I don't start at the average value of 0, I actually start at the maximum value. It's going to be a cosine function, so it's cosine. And now we have to figure out the part that has x in it, the angle. So that's the hard part here, figuring out this angle. Our goal is to have our angle between 0 and 2 pi, because that's the standard cosine function's angle is between 0 and 2 pi. That's where the function starts and ends. And now we're going to use what we know about this graph. We're going to start with the x values because x is going to go inside here in the angle. And x represents angles in this graph. So x is between pi over 3 and 8 pi over 3 for a complete period. And now we need to change these numbers somehow through algebra to 0 and 2 pi, and we can figure out what our angle will be. And then we can take whatever's in the middle here after the algebra and put it in as our angle for the function. So the easiest way to do that is to start by making this left side 0. And to do that, I need to subtract pi over 3 from all three sides. So this will be 0, this will be x minus pi over 3, and this will be 7 pi over 3. And now we've already got a starting point of 0, so I don't want to add or subtract anything anymore because that would change my 0. So I just want to multiply by something now, because if I multiply something by 0, it stays the same. But I need to multiply something to change 7 pi over 3 into 2 pi. So we'll go off to the side here. So this is our side work. And we need to multiply 7 pi over 3 by something, let's say k, to get 2 pi. Okay? And so we have to solve this equation for k, and then we'll know what to multiply all three sides by, so that this will be a 2 pi. So the easiest way to do that is to divide both sides by 7 pi over 3, or multiply both sides by 3 over 7 pi. So the 3's cancel, the 7 pi's cancel, and you have k. 2 pi times 3 is 6 pi. Sorry, I forgot. The pi's cancel here. So 2 times 3 is 6 over 7. So k is 6/7. That's what we're going to multiply all three sides by here. When I multiply 0 by 6/7, I still get 0. So see how this is good because we have our 0 to match. I'm going to multiply the middle by 6/7. So I'm going to have 6/7 times the quantity x minus pi over 3. I could distribute it if I wanted to, but I don't want to. And then we already know if I were to multiply 7 pi over 3 by 6/7, let's see, let's go ahead and write this out. We're going to multiply all three sides by 6/7. We'll just show that here. I've got the left side 0, the middle is 6/7 times the quantity. The right side should give us 2 pi, and you can check this. 6 and 3 reduce to 1 and 2. The 7's reduce to 1's, so you get pi times 2, which is 2 pi. And so now we have squeezed our angle between 0 and 2 pi, so this is the angle that goes into the transformed function. So we're going to use this template, and we know the equation of this graphed function is y equals 5 times the cosine of our angle, and our angle is given here, 6/7 times the quantity x minus pi over 3. And this is one equation for this graph. It has the proper phase shift, it has the proper amplitude, it has the proper period.